Seated and come to order. Court's again in session.
Ladies and gentlemen of the jury, have you reached a verdict?
Yes, we have, Your Honor.
Will you please hand your verdict to the bailiff?
Circumstantial evidence can be happened, even though no one saw it happen.
We, the jury, in the above entitled action, find the defendant, Harris Volney, guilty of burglary, a felony in the first degree, as charged in the indictment.
Circumstantial evidence is also used in science, and it's an extremely valuable scientific tool. The scientist is often concerned with things that he can't see, and he uses circumstantial evidence often to prove the existence of these unseen things. For example, many of you have heard of atoms and molecules. You may know that all the materials in our world are made up of tiny particles of stuff. You may also know that atoms and molecules are far too small to be seen by the human eye. So how can anyone prove the existence of these things if we can't see them? Well, in court, a man can be proven guilty even if no one saw him commit a crime, so long as there is enough circumstantial evidence to prove his guilt. Now, no one has seen the atoms and molecules of our world, but I'm going to try and prove to you that they really do exist. I'm going to use circumstantial evidence. I'm going to present several pieces of evidence, some simple demonstrations here, and a few pictures. I want you to add this evidence up in your mind and see by the end of this film whether or not I've given convincing proof of the fact that atoms and molecules really do exist. I'll need this machine here for my first piece of evidence. Here is a piston that can slide up and down. Under the piston are some BBs. Now, when I turn on this motor and touch the cylinder to this vibrating bit, the BBs are sent jumping. See how the continual bombardment by these very small BBs holds the large piston up. If I put a weight on top of the piston, it goes down a little. But the bouncing BBs still hold it up. It certainly seems that a continual bombardment by small objects can hold up a much larger object. Here is a similar cylinder and piston, but this piston has no BBs under it. Now I'm going to blow air in under the piston. And close the valve so that none of the air can escape. Now, what's holding the piston up? The piston is being held up by air. But it acts exactly the same way as it did when it was held up by the bombardment of the tiny BBs. It certainly looks as if air might be made up of tiny invisible pellets or particles far smaller than the BBs. Something we can't see is holding the piston up. Now, this is one piece of circumstantial evidence that suggests very tiny invisible particles are bombarding the piston and holding it up just as the BBs did. This leads us to think that air may be made up of tiny particles. Now let's go on to the next piece of evidence. Watch this. The marbles are a lot smaller and lighter than the sponge, but if they're moving fast enough and if there are enough of them, they can push the sponge around. In other words, a lot of fast-moving small objects can push a large object around. Keep that in mind while I show you the next piece of evidence. Let me show you how this small apparatus works. If I draw some smoke through this hole into the chamber and shine a light through here, I can then look through this window with a microscope and get a magnified view of what's going on inside. Let's try it. Now, smoke from the match is inside the chamber. Okay, let's take a look at the smoke through the microscope. The bright spots are particles of smoke magnified so that we see them 100 times bigger than they really are. Now, what's making them dance around? What's pushing them? Well, I believe they're being pushed around by tiny moving particles that are too small to be seen even through the microscope. I think these tiny particles are pushing the particles around just as the marbles push the sponge. The movement of the smoke particles is pretty good circumstantial evidence that the air is made up of tiny somethings that are moving around and hitting the larger smoke particles. Let's call these tiny somethings that seem to be doing the pushing molecules. Now, we can't see molecules, but it certainly seems that we can see their effect. And it does look as if air is made up of these tiny molecules. Now, I'm going to say that water is made up of molecules too, just as the air is. And I'll show you another piece of circumstantial evidence to back up what I say. Water appears to come out of the tap in a continuous stream, but I say it's made up of tiny particles which we call molecules. This is a chemical made up of small individual chunks of material which we will be able to see only with the aid of a microscope. If we mix some of this chemical with the water, and put a drop of it on a slide, we then can use a microscope to see what's going on inside the drop of water. There it is again. Something is pushing the little chunks of chemical around. What's making them move like that? It seems as if the only reasonable answer is to assume that water is made up of molecules that are moving, and that they push the relatively large chunks of chemical around the same way the air molecules push the smoke particles. We can't see the molecules, but we can see circumstantial evidence that indicates they are there. All right, you've seen evidence suggesting that air, which is a gas, and water, which is a liquid, are composed of tiny particles. And you know these particles are called molecules. Now, what about solid materials? Are they made up of molecules too? Here is a piece of solid material. It's a crystal called calcite. As a matter of fact, most solid materials are crystals of one kind or another. Such common things as copper and sugar are actually crystals. Now, as you can see, this is pretty hard stuff. But here's something strange. If I take an ordinary single-edged razor blade and just give it a light tap, the crystal cleaves evenly. I think this is a pretty good piece of circumstantial evidence. It leads me to believe that solid materials are made up of tiny building blocks, just like air and water. However, I doubt that you'll accept this as very good evidence unless I back it up with some more information. Now, this is what we call an atomic model. Each of these little spheres represents one atom. We don't know exactly what an atom looks like. These are only symbols that stand for one atom. The sticks represent something holding the atoms together in groups. So far, I've been showing you circumstantial evidence to prove that all material is made up of tiny particles. Now, we've been calling these particles molecules. So what about atoms? We believe that the tiny particles called atoms are actually the building blocks from which molecules are made. Now, if that's true, then the atoms must be much smaller than molecules, and that would make an atom extremely small. Why, for instance, do I think that this solid material, a salt crystal, is made up of atoms? And why do I think that the millions and millions of atoms inside here are arranged like this? I'll show you again another piece of circumstantial evidence that helps convince me. Remember, a calcite crystal is very hard. However, it can be cleaved with a sharp edge and a light tap. Now, this is what I believe happened when I split the crystal. I believe that the crystal split along even rows of atoms, like this. I believe that if this crystal were not made up of tiny particles, and if these particles were not arranged in even rows, it wouldn't be so easy to split such a hard material in this manner. I can show you more circumstantial evidence to back up what I say. Have you ever made rock candy? You do it something like this. First, you pour a lot of sugar into some hot water. Then make sure it all dissolves. After the solution cools, you hang a small piece of a sugar cube in the jar. Now you'll have to go away and wait. About 36 hours later, you'll find something like this. The sugar that was dissolved in the water has formed into crystals around the string. Now let's watch another crystal growing, but this time we'll watch through a microscope. This crystalline powder is called salol. It melts easily. And as it cools, we should be able to see the crystals growing in it. What's making the crystal grow? Well, I say that there's only one way to explain why crystals grow in this way. I think that these particles are the basic materials that the crystal is made of, and that they are either atoms or molecules. I think that they join on to the piece of crystal in regular rows and make it grow. They must attach themselves in straight rows one after another because the edges of the crystal remain straight. Okay, I don't think crystals would grow that way if they weren't made up of tiny particles. And so I think this is another good piece of circumstantial evidence to prove that there are such things as atoms and molecules. Now I'll show you another piece of evidence. These two rods are made of lead and are connected to a source of electricity. The feathery material on this rod is lead too. Now I'm going to reverse the wires. Watch what happens. We let the camera speed up something that would actually take a longer time to happen. The lead is disappearing from one rod and seems to be collecting on the other. But can you see any lead moving from one rod to the other? Why can't you? You can't because the lead is moving from one rod to another in separate tiny little bits that are too small to be seen. These bits are atoms with electrical charges on them. At least that's what I think. It seems that electricity has something to do with the movement of atoms of lead from one rod to another. If I reverse the wires again, the atoms go in the other direction. Well, that introduces a new idea. It seems that electricity and atoms are related in some way. You can think more about that later. Actually, all I wanted to do here was introduce another piece of circumstantial evidence to prove the existence of such things as atoms and molecules. Let me show you the best that science has been able to do so far in photographing these atoms and molecules. This is a picture made by shooting X-rays through a crystal. These are not pictures of the atoms that make up the crystal. But this X-ray diffraction pattern does suggest a regular order, very much like the order in which we believe atoms are arranged inside crystals. This second photograph was taken through an electron microscope. And this is a molecule. It is 1/1,000,000th of an inch wide. The molecule is made up probably of millions of atoms. So naturally, the atoms are too small to be seen here. This third photo was taken through a very special kind of microscope called an ion microscope. We actually believe these dots are blurred pictures of individual atoms, and that this is the closest we have come yet to actually seeing a single atom. Now, do you believe in atoms or molecules, or at least that all the things around you called matter are made up of tiny individual building blocks? There are many, many good pieces of evidence that have been discovered by scientists all around the world. And all of this evidence seems to prove that there are such things as atoms and molecules. Today, much of science is based on the fact that these atoms and molecules really do exist. Many things that used to be difficult to understand can today be explained in terms of these tiny, unseen building blocks. For example, here are 5 clear liquids that, to the naked eye, look exactly alike. When I pour this one, nothing happens. This one burns. This one puts the fire out. This one etches the copper plate. And the last one, I won't pour because it's radioactive. 5 clear liquids that all look exactly alike. But if we could see closely enough, we would see that the molecules and atoms out of which each liquid is made are very different. And it's because each liquid is made up of different kinds of atoms and molecules that each one of them acts in a very different way. Water did nothing. Acetone burned. Carbon tetrachloride put the fire out. Nitric acid etched the copper plate. And the radioactive cobalt